What if we've been wrong about ancient engineering? In an age of steel and concrete, our buildings crack and crumble. But thousands of years ago, without computers or rebar, ancient builders created structures that have withstood the test of time and the violent fury of countless earthquakes. From the peaks of the Andes to the temples of ancient Greece, our ancestors didn't just build to last, they built to move. Their secret wasn't brute strength, but brilliant flexibility. They understood something we are only now fully appreciating. To survive an earthquake, a structure must dance. Let's travel to Peru, home of the Inca Empire. Here, at sites like Machu Picchu and Ollantaytambo, you'll find some of the most famous masonry on Earth. But the true genius of these walls isn't just that the stones fit together perfectly without mortar. It's how they fit. The Inca built with polygonal walls, stones with multiple asymmetrical sides and angles that all lock together like an insane three-dimensional jigsaw puzzle. During a seismic event, this design is key. The stones don't form a rigid, brittle wall. Instead, they shift, they vibrate, grate, and even bounce slightly against each other, dissipating the earthquake's energy. When the shaking stops, the stones simply settle back into their original locked position. It's a perfect example of what engineers call dynamic stability. But the Inca weren't the only ones. On the other side of the world, in ancient Greece, builders employed a similar principle of isolated movement. Look at the Parthenon. Its massive architrave blocks, weighing tons, were connected not with rigid mortar, but with sophisticated metal clamps dipped in lead. The lead acted as a sacrificial, flexible layer, allowing the stone to shift and absorb shock without shattering the clamp or the stone itself. It was a primitive but incredibly effective seismic isolator. And then there's the mysterious kotatsu technique from Japan. At the 1,300-year-old Horyuji Temple, the massive central pillar isn't anchored into the foundation. Instead, it rests in a stone socket, standing on it like a pencil balanced on your hand. During an earthquake, the entire pagoda sways, and this pillar acts as a giant, counterbalancing pendulum, swinging in the opposite direction to counteract the motion and stabilize the structure. It's a breathtakingly simple application of physics. These were not accidental discoveries. They were the result of centuries of observation, experimentation, and a deep, intuitive understanding of the forces of nature. They didn't fight the earthquake. They worked with it. In our quest to build bigger and taller, perhaps we have forgotten this fundamental wisdom of the ancients, that sometimes, to stand strong, you must first learn to sway. What modern techniques do you think will stand for 2,000 years? Share your thoughts below.